How many pairs of positive integers a comma b are there such that a and b have no common factors greater than 1, so they are prime to each other. In other words, these cannot be reduced. And this is an integer. Well, we want this to be an integer. If you write like this and stare at it for a while, you do not make any progress. The key is that they somehow magically mix with each other and then produce an integer. That is an exceedingly difficult way of thinking. What you should do is to have a whole bunch of integers and have only one fraction sitting there so that you can say that fraction is an integer. So we have two fractions, which is bad news. Let's make it into one fraction. How? Why don't we multiply by b everywhere? Then what do we get? A plus, see, it became just a non-fraction. So I'm multiplying by b, so I get 14b squared over 9a equals kb. Okay, now we are going to dwell on this. So let's isolate it so that we can clearly see what it is made of. Okay, k is an integer. After all, we want it to be an integer. B is an integer. They told us so. A is an integer. They told us. Now, if you multiply integer and subtract integer, you get an integer. In other words, this is an integer. In other words, the denominator's got to disappear. Well, it may have canceled. No, they told us they do not cancel. So, how can I make this a disappear? Well, b is no help, right? And this 9 is just compounding the problem. Let's forget about 9 here. A has to disappear with this 14. That's its only hope. So a could be one numbers. When you have 14 over a, it has to be an integer. So 14 over 1 is an integer, 14 over 2 is an integer, 14 over 7 is an integer, and 14 over 14 is an integer. So a can only be those. What about this 9 and b squared? Obviously, b squared took care of 9. Yeah. What is b? You kind of want to say 3. Well, what if b was 9? Yeah, 81 over 9, it would be an integer too. So you say, okay, b was 9. But what if b was 27? What if b was 81? What if b was 99? B could be lots of things, so we cannot conclude anything here. If they say find the smallest b, maybe we could do this here, but they didn't say. We got to find all possible b's. What do? We are in the wrong place. That's what it is. So we got to have a b in the denominator to deal with it. Only then you can, reduce the possibility. If this was reversed, if we had something like a over 14 here, a could be 14, I could be 28. This could be any multiple of 14. There's just too many possibilities. We need to bring that b to the denominator. So how do we do that? Let's make this the only fraction in the game, and let's make everything else integers. So I will multiply by 9a everywhere. So I get 9a squared over b, and this becomes clean integer 14b, and this got to deal with 9a and multiply by k. Okay, so 9a squared over b equals, I will put this 9ak, this is already in the right order, minus 14b. Okay, let me tell you, 9 is an integer, a, they told me it was an integer, k is supposed to be an integer, 14 is an integer, b, they told me it was an integer, so if you multiply integers and subtract integers, you get integer. This thing is an integer. A is an integer. Okay, now, how can I get rid of this b? 9 over what would become an integer is the question. 9 over 1 is an integer. 9 over 3 is an integer. 9 over 9 is an integer. Okay, so those are the possibilities. Now what? Now, this got to become integer. So what are we going to do? We are going to quickly plug in all 4 times 3 possibilities. So we are going to do 12 possibilities. Many of these numbers could be evaluated in your head, but since I'm showing you, I'm going to write it. So let's do. I will pick one here and go through them, and pick the next one and then go through them. So I will go systematically. So 1 1, 1 1, 1 1. This is an integer. This is fraction. No way this is going to add to integer. Out. Now, I did 1, 1. So now I'll do 1, 3. So 1, 3, 1, 3. Okay. This is a fraction, but this I cancels. So I got 14 over 3, 1 over 3. So it's 15 over 3. That's an integer. So what was it? Was 1 comma 3 I was doing. Okay, so we had one success case. Next. Now it's a 1, 9, right? So 1, 9 and 9, 1. No, 1, 9. It is 1, 9. Okay, 9 cancels. This is an integer, 14 over 1. This is not, so no way they're going to add. Okay, then I exhausted 1, so I will go with 2, 1. So 2, 1, 2, 1. This is an integer. This is not, so no way. And 2, 3. Three cancels, and 2 cancels. I get 2 over 3, 7 over 3. If I add it, it becomes 9 over 3. This thing worked. That was 2 comma 3. Works. Okay. What's the next one? Then 2 comma 9, right? So 2, 9, 2, 9. 9 cancels, 2 cancels. Oh, this guy became a integer. Whereas this is not, so therefore they will never add up to integer. So that's out. I just did what? 2 comma 9, right? Okay, I exhausted 2. Now let's go with 7, 1. I know it's not gonna work because I got 7, 1, 7, 1. This is an integer, and this is not an integer. So basically, having 1 in B is a bad news. 7, 1 didn't work. Then comes 7, 3. Get the feeling it would work. 7, 3. Okay. This cancels, so I guess 3 on the bottom. Bam, cancels. I got 2 on the bottom. Okay, common denominator of 3. Numerators are 7 and 2. Add them, it's 9 over 3. Bingo. So 7 comma 3 worked. Next. What about 7 comma 9? 7, 9, 7, 9. 9 cancels. This cancels. This is an integer. This is not. So therefore would not be. Okay, now I did 7 comma 9, right? So I ran out of all 3. Now I'm going to use 14 and 1. We know 14 and 1 would not. This is integer. 14 and 1 is not an integer, so therefore would not work. I would not write this normally. You would not write it. You would think 14, 1, that's integer. 14, 1 would not be, so you don't even try that. But I'm showing you the steps, so I will write it. So 14, 3 now. 14 and 3. 14, 3. 14 canceled out. This became 1/3. Okay, 14 plus 1 is 15 over 3. Works. Okay, last one. 14, 9. 14 over 9. 14, 9. 9 cancels, 14 cancels. This is an integer. This is not. So therefore, doesn't work. So these 4 are the possible combinations of A and B that would give you an integer. So there are 4 ways.